Hi, this video is for Wednesday, April 1st for calculus. So we're going to continue our lesson on L'Hopital's rule, and before we do that we're going to review the derivatives of some e to a certain power and then the natural log of x. And I also wanted to remind you that e to the 0 equals 1 because you're going to need those ideas for later. Okay, so I've typed all of this on your notes page for the day. So there is a slight error though, where it says this one, the derivative of e to the x to the third. This is the correct one. It should say 3x squared e to the x to the third. On your notes page, it just says 3x right here. It doesn't have the squared. It should have the squared. And if I can remember, I will fix that when I'm finished with this video. But if I don't, know that this is the correct one. Okay? Alright, so now that we have talked about all of these things, or you've seen them here, we're going to go to example 1, and we're going to be talking about indeterminate forms still. That's the reason why L'Hopital's rule exists. So if you get a 0 over 0, or an infinity over infinity, when you try to use direct substitution when finding limits, that's why we use L'Hopital's rule. Okay, so I'm going to erase this. Alright, so we're ready for example 1. Okay, so example 1 says, evaluate the limit as x approaches 0 of e to the 2x minus 1 over x. Okay, so if you remember from yesterday, we have to find the derivative of the top and the bottom. So the derivative of e to the 2x, if you're looking at your notes page, is 2e to the 2x. Because the derivative of the power itself is 2, so that 2 gets moved to the front, and then e to the 2x stays e to the 2x. The derivative of 1 is 0, and the derivative of x is 1. Okay, so now we have this problem. Okay, so now if we use direct substitution, we're going to have 2e to the 0 over 1. Now if you remember, e to the 0 is going to equal 1. So 2 times 1 is 2. So the limit's just going to be 2. Okay? So we found the derivative of the top and bottom just like yesterday. Then we used direct substitution. Okay? So hopefully that made sense. Now we're going to try example 2. Alright, example 2, now we're going to have the indeterminate form, infinity over infinity, if you were to plug in direct substitution. So I'll show you. It says, find the limit as x approaches infinity, and we have natural log of x over x. So if you were to directly plug infinity in for x on the top and the bottom, you would just be left with infinity over infinity, and that doesn't help us. So we're going to find the derivative of the top and the bottom. So the derivative of natural log of x is 1 over x, and the derivative of x is 1. Okay, so now we're finding the limit as x approaches infinity of 1 over x divided by 1. And anything divided by 1 just equals itself, so we're really finding the limit of 1 over x. So if we plug infinity in there, do you remember what happens when infinity is on the bottom of a fraction? Well, that means the whole thing is going to equal 0, so that means that the limit is 0. Okay? So that's example 2. Alright, so those are the 2 examples for the day. We're going to do 2 practice problems now to make sure that you've got it. And then you'll have a Google form on these things. And I'm going to check the Google form so that hopefully there are no more problems like the last 2 days that we had. Sometimes technology is supposed to help you, but other times it just annoys you. So we're doing the best we can here. Alright, so here are the practice problems. Alright, number 1, it looks like this. It says find the limit as x approaches 0, 1 minus e to the x over x. Okay, so when we find the derivative of the top and the bottom here, the derivative of this is 0. And when you find the derivative of this, because it's a minus right here, it's going to be negative e to the x. And the derivative of the bottom part is 1. Okay, so now we're going to plug in our 0. So when I plug in 0, we have negative e to the 0 over 1. So e to the 0 itself equals 1, but because of this minus, it's going to equal negative 1 over 1, and we know that that's just going to equal negative 1. Here, I'll write that a little clearer so you can see that better. Okay, so hopefully you're good with that. Alright, we're going to try the second one now. Okay, number 2 looks like this. Find the limit as x approaches 0, and we have e to the x minus 1 minus x over x. Okay. So, you see that top part that says minus 1 minus x. So, you could rewrite this problem if that looks a little tricky. So, we have e to the x minus 1 plus x, because this negative goes to this whole quantity. So, it'd be minus 1 plus x over x. Okay, and now we're going to find the derivative of the top and the bottom. So, the derivative of e to the x is e to the x. The derivative of negative 1 is 0. The derivative of x is 1. Okay, so it looks like that now. And now we're going to plug in our limit as x approaches 0. So e to the 0 is 1. So 1 plus 1 is 2. So the limit is 2. Okay. Now, that concludes the practice problems. So if you have any questions or you need any help, please email me or message me and I'll get back to you. And I think you're all doing a great job, so keep up the good work. And tomorrow I probably won't post a video because I'll just have you do more problems on L'Hopital's rule. But I hope this helps, and I really wish that I could see you soon, but I guess we're doing this through April 30th now. So, see ya.